So right before these graphs, I want you to highlight this right here. Polynomial functions can be described by its degree. There are even degree polynomial functions where the biggest degree is an even number, and odd degree polynomial functions where the biggest degree is an odd number. And on the side of your paper there, the top of page 39, we're going to make a little note that's going to really be helpful. We'll start with the odd functions. These are y equals x, y equals x cubed, y equals x to the 5, dot, 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 and anything can happen after that. Like you could have y equals 3x plus 5. That's a line. If the highest degree is an odd number, that makes it an odd function. And we're going to make a note that the end behavior, how the graph acts at the end of its life, positive infinity and negative infinity, the end behavior, boy, I spelled it. Spelled the Canadian way, has a U, is that right? I don't know, I think so. End behavior the end behavior acts like a line. Well, what do I mean by that? Well, if you have a positive coefficient, if I think about y equals x, this is my y equals x. The end behavior is where those arrows are. Every odd function that has a positive leading coefficient is going to start in the bottom left and end in the top right, just like a line would. If your leading coefficient was negative, think about a line with a negative slope, it would go down from left to right, and your end behavior would be like this. So an x to the cube graph is going to start at the same place as a line. There's just more squiggles and things happening in between that we've got to figure out. And even functions. If the highest degree is an even number, like an x squared graph, then the end behavior acts like a parabola. So if you have a leading coefficient that's positive, a positive x squared, well, this is what a parabola looks like when it's positive, and there's your end behavior as a result. So if you had a positive x to the 202 graph, it would start in the top left, do a bunch of crazy stuff in the middle, and then end in the top right. And of course, negative parabolas, they open down, and our end behavior is there. So we're going to use this idea of, I know lines and I know parabolas, and since I know lines and I know parabolas, I know what the end behavior is, and this is going to be our first hint for graphing these, because we're going to have to graph all sorts of equations. Some you already know. You know how to graph lines. Lines are odd functions. Their end behavior acts like a line. Surprise, surprise. Okay, so the end behavior here, when it's positive, it's like this. If you have a negative leading coefficient, then your end behavior is there. Parabolas are even functions, and they act like parabolas because they're even functions. If you have a positive 2x squared, then your end behavior and your parabola opens up. If you have a negative leading coefficient, then your end behavior opens down. And in grade 11, you learned how to complete the square, find the vertex form, or factor to find the x-intercepts, and draw your graph. These graphs we know already. The graphs that we don't know is how do we graph x cubed graphs that aren't simple ones. Like simple x cubes, you've done with transformations. You can move it left, right, up, and down. But if you had a graph like this, x cubed plus 2x squared plus x minus 2, okay? The leading coefficient is positive. So in my head, I would think of a line and say, there's my end behavior. Does that match up? Look at that. Matches up. Starts in the bottom left, ends in the top right. If I have an odd function that is a negative leading coefficient, I think of a line with a negative slope. There's my end behavior. Does that match up? It does. It starts in the top left, ends in the bottom right. We're going to graph like x to the 4 minus 5x squared plus 2. Get this W-shaped graph. But for right now, the only hint we're learning is the end behavior. Since it's an even function and it's positive, I think of a parabola with a positive leading coefficient. There's my end behavior. Does that match up with this one? Does it end top left, end top right? Start top left, end top right? Absolutely. It just has some bumps in the middle, different than a parabola. Sometimes it has bumps and bends. This next one's kind of just like, first one had two valleys and one hill, if we're talking about what we did in the lab yesterday. The next one doesn't have any valleys or hills at all, so it's kind of weird, but the leading coefficient is negative. It's an even function, so I think of a parabola. A parabola that's negative, its end behavior would be down there. And sure enough, the end behavior of this one is down there. And we can keep going. We can do an x to the 5. X to the 5 is odd. I think of lines. Positive line, there's my end behavior. Sure enough, this positive x to the 5 graph started in the bottom left, ended in the top right, and just had a whole bunch of crazy stuff going in between. And finally, negative leading coefficient, I think of a line with a negative slope. So my end behavior should start top left and bottom right. I find this visual the easiest way to remember. The textbook has tried to describe it in words. Okay? So here's them describing it in words. You have an odd degree polynomial. And I would say, for me, the words would be harder to remember. But if the leading coefficient is positive, they say, just remember that as x goes to negative infinity, the graph falls to the left, and as x goes to infinity, the graph rises to the right. Memorizing that for a positive odd degree function, I think is a lot harder than going, oh, odd acts like lines. Here's my positive line. There's my end behavior. I don't have to remember any words. What does it say? As x goes to negative infinity. So they're saying, as you go this way, the graph falls to the left. See how my line does that? And as x goes to positive infinity this way, the graph rises to the right. That shows up in their words, but I think that the graphic of drawing a little line is way easier to remember the end behavior. Same thing here. Right? I would just remember a line with a negative slope, there and there. Even ones, I just think of my parabolas. There's my parabola, there's my end behavior. Even one, here's a negative parabola, there's my end behavior. And if the exam forced you to describe that in words, I think you could do it. All right? But the picture would be the way I would start, because it's really easy to remember. Okay? Now when we graph these, oh the next page. Just one more thing to highlight. There are something called local maximums and local minimums. And these become very important in calculus. Actually, what we do in grade 12, we still have to use technology to find this, for the most part. It's setting us up. This is the reason this is called a pre-calculus class. Calculus can find those maximum points really easily. Okay? Why are they called local maximums? Because if you just drew a circle close to that point, that's like a little city, a little village. Somebody is the tallest in that village. They're like the local maximum, the tallest person in that village. They might not be the tallest person in the world. They might be, right? In this first village that I circled, that's the highest it ever gets in the whole graph. The absolute maximum lives in that village. Here we have another village. There's someone who's the tallest in that village. They would be the local maximum there. So a local maximum just says, if you just look close by, is there a biggest point in that vicinity? And this graph has 2 local maximums and 1 local minimum. Oh wait, let's go to example 1. And we're going to sketch these graphs. So the first thing I'm going to do is underneath both of them, I'm going to draw a grid. And in this unit, we're going to learn better and better techniques for graphing. But right now, all we have is the end behavior, is the only strategy we have. Other than that, you just have to pick points. So for this first one, do you see that it's odd? So the first one, the biggest one is an x cubed. Odd graphs act as lines. The coefficient in front of the x cubed is positive. So I think of a line, and I think of its end behavior. And when I go to graph my graph, I can actually start with an arrowhead there and there. I know that that's going to happen. My graph has to start in bottom left and end in the top right. If I want to know what's happening at other places, a very powerful strategy is a table of values. It's very powerful, but it's also usually the most time-consuming strategy. Like when graphing lines, do you make table of values anymore? Or do you use y equals mx plus b? Right? When graphing parabolas, if you know the vertex and where it is, you're going to use that. But if you're ever stuck, you can always do a table of values. So I can plug in 0 and get 0. That gives me a point there. I can plug in 1 and get -2. So that gives me a point there. Okay, I'm going to label that point so that my graph has a scale. Drawing a graph without a scale always creates a half mark. It's an E9 error. Right, I can graph, I'm going to put in 3 and get 0 again. And if I did enough points, I don't know, let's say I did a lot of points, I'd be like, oh, I think this is the shape of the graph based on the points that I've gotten. I didn't do very many points. You'd probably have to do quite a few more. But right now, I want you to see that you can get the end behavior, and then you can make a table of values to find you other points. And there has been on the final exam times where that is the best strategy for graphing. Every single shortcut that I will teach you actually worked terribly in that question that they gave you. And everybody who tried a shortcut got it completely wrong. And the students that went back to, I just need to do a table of values to see what's going on. Sometimes table of values are nice to check. Did I screw up my shortcut? Does it make sense? So this second one is a negative x to the 4 graph, which is even. Acts like a parabola, and the leading coefficient is negative, so I know my end behavior is here. So on my graph, I know that's going to happen. And then I would just start doing table of values, which is kind of annoying. Right? I could plug in 0 and get 3. I could plug in other values, and eventually I would get a bunch of points that would fill in this graph. I know that you could plug in 2 more points. I know that you could plug in 5 more points. I know you could plug in 20 more points. The more points you plug in, the more accurate it's going to get. Okay? But I also want you to, I'm not even going to do that right now. I know you could do that. Right? You might, I don't know, maybe this one, I don't know, maybe it goes like this. I don't know. We'd have to plug in points to see that. And then you would draw your line through all your points, ending with your end behavior. Okay, I'm going to get you to circle 5, 6, and 8.